Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. I'm your host, Leon Jones, and I'm doing a trifecta tonight because I'm getting into structural design. And the reason why I'm getting into the structural part of design is because there was a 12-story condominium complex or high rise that collapsed in the state of Florida. And there's still a number of people who haven't been found. But it's very important that you understand the structural part because it's that structure that holds all the loads in place because you have dead loads and you have live loads. Human beings are what we call live loads. Furniture is what we call dead loads. When you build a building, there's a factor of safety. Now, let's say the factor of safety is 2. You want to build your factor of safety to where it's 4, so you have room for error because nothing is built perfectly. So, what I am going to title this drawing is let's review structural prints. Let's review structural prints. Now, again, let me share my screen. The presentation comes from a book that I used for a class at Ivy Tech called BCom 102. It's print reading for construction, residential, and commercial. Again, this is fair use, but I want to get into structures because it's very important. And for the most part, being a civil engineer, you get into structures, that's the meat and potatoes. You even need a structure when you build a bridge, believe it or not. You need your footer. Your footer is designed by creating a mud mat and your rebar, and you test the concrete. So we're going to talk about structural prints. Now, the objectives, for the most part, we're going to identify different types of structural construction systems. We're going to recognize various types of concrete floor systems. We're going to understand concrete reinforcing notation. We're going to recognize reinforcing steel on prints. We're going to read beam and column schedules and identify various steel members. Okay, now, first, we get into green building. Now, why do we use green buildings? Well, we're basically reusing waste. We're also evaluating waste for other uses before disposal. Now, when we deal with construction materials, we can recycle them like gravel, concrete material, lumber, and steel. And these materials can be useful on other sites. Now, some structural systems. As I got up here, commercial and industrial buildings are basically constructed around a structural framework of reinforced concrete and structural steel. Now, of course, there are 2 major groups of above grade structural systems. First, you have your concrete construction and your steel construction. And on this PowerPoint slide, you are seeing an example of a commercial steel structure. Okay, types of concrete construction. Well, you have what we call cast in place concrete, which you basically cast your structure at the construction site. Now, for the most part, when it comes to casting in concrete, you're going to have weather. So cast in place concrete can be affected by cold, hot, or wet weather. Then you have what we call casting plants. Like you may get some of your what we call precast concrete. It's cast at a plant. Now that precast concrete should be small enough to transport. Then if you want some decorative concrete, it's known as architectural concrete. It's exposed to view to create a finished space. Now we have concrete floor systems. There's a one-way slab system. And in that one-way slab system, there's a main reinforcing steel span that goes in one direction, and you also have supporting members that run parallel to each other. Then you have a two-way slab system. It's basically the opposite of a one-way slab system, where, okay, instead of main reinforcing that goes in one direction, where you have it in the one-way slab system, you have the main reinforcing going in two directions. Now, the difference between a one-way and a two-way, there's a flat plate slab system, and then there's a waffle slab system. It's a type of two-way slab system, and it basically uses pans or domes to form a support structure. Now, of course, when we deal with concrete, each type uses concrete reinforced steel rods known as rebar. Now, again, I'm showing you an example right now of a one-way slab system. This looks more like a waffle system, but what you're seeing is how it's created. You have your beam side, your girders, your soffits. It's rectangular. It's your column. And your two-way slab system. Remember I told you about the flat plate, your columns, your drop panels, your flat slab here, your round columns. Then your waffle system. This is in some buildings. Looks just like a waffle. That's why they call it a waffle system. Then we talk about steel reinforcement. Used in all types of concrete structural systems, your floors, your columns, your beams. It's available in deformed or plain bars. Now, to prevent rust in the holidays are scratches you get in your reinforced steel. They galvanize it or they utilize epoxy. That's the green material that you see on rebar. And what rebar does, it gives you that tension. So it provides additional strength to resist forces of compression, tension, and shear. Now, the identification of rebar is designed on a drawing by the number of bars, the size of bars, the placement and spacing of the bars. Now, the drawing identification. Now, here you have two number 5 bars. Now, when you see the number 5, all rebar is done in eighths. And you're utilizing the diameter of rebar. So when you have a number 5, you're dealing with 5/8 of an inch and 19 feet at 2 feet 6 inches on center. So again, the number 5 bar indicates 5/8 diameter. Now you also have steel reinforcing bar identification marks. Okay. You have the type of steel, carbon, low alloy, and axle. So looking at your rebar, you got your ribs. You got your initial of your producing mill. You got your bar size. You got your type of steel. So we're looking at a bar size of 11. We're looking at these are your line system grade marks and your number system grade marks. So you have some that are grade 60 and some without a number. But basically, you have grade 40, 50, 60. But basically what you have here, when it says bar size, it's 11/8. So it's about 1 3/8 of an inch. And we're looking at carbon. Now we get into columns. Now your columns are basically vertical support members designed to carry anticipated final load of the building structure. And you have concrete columns. They're basically reinforced with rebar. Now, on your drawings, columns are identified on drawings by a grid system of letters and numbers. And they're usually specified on what we call a column schedule. Now, column schedules should identify the location of the column, size of the column, number, size, and location of reinforcing bars, size, and spacing of ties. And what you see again is an actual column, and you see a column schedule. Again, your base plate, your anchor bolts, this is your column base plate, and this is an actual column. And you could see it's already been poured, the footing, because the column, you need the columns to hold up your structures as well. Again, we're dealing with live loads and we're dealing with dead loads. Now also beams. Now in a house, you have beams. They're what we call floor joists in the house. Now here in an apartment, I have a beam that runs horizontally. Now, usually beams run horizontally below a floor system. And what supports beams? Other beams, girders, or columns. Now, stirrups. Let's go back to the column. What you have right around here that are tied in place, these are stirrups. You have them on columns, and you also have them right here on beams. Again, stirrups hold bars in place and they provide extra reinforcement. Now, something that you have to understand too when they're pouring concrete, you have another item called a chair. Usually your 3/8 or 5-inch chair that actually supports your rebar. So your rebar doesn't actually hit the concrete. Because you know, one thing about rebar, it can rust. This is again why you have to galvanize it or put it in epoxy. And you know, rebar gives that concrete again the tension. Now different reinforcing steel supports. Right up here, these are your bar supports. These are known as your chair system. All types of supports. Now again, everything is going to be in the video for you to review again when you watch this video. I'm just giving you an overview of what's involved when it comes to structures. Here are more chairs. Different sizes, different types. Now, just like your column, you have a beam schedule. Your size, your beam mark, your reinforcement, your stirrups. Now, this is a good one. Beam and slab reinforcing. Now, you see how you have your slab and going across is your beam. You have your stirrups that basically are holding your rebar together. You also have your chairs. Your chairs are also holding a rebar up. Now, usually when they do a building, they're utilizing number 4, 5, and number 6 bars. Now, the highest bar they have, I believe, is a 16, which is 2 inches in diameter. I mean, that's a very thick bar, very heavy bar. Now, when we deal with structures, there's a framing plan too. Now, framing is usually done by wood. Most of your residential homes are done with framing. Now, again, when it comes to construction, you're going to have to do some cutting and splicing. And when you splice reinforcement, you have to understand it's always going to be needed when length of beam or column exceeds the length of rebar. And of course, bars overlapped by a length are given in a number of diameters. Like 30 diameter minimum lap. Number 4 bar equals 1/2 by 30 diameters, which equals 15-inch overlap. Now, how did they get 15? Well, they took 30 and they multiplied by 1/2 to get 15 inches. Now, where do they get that 1/2 from? Very simple. A number 4 bar. A number 4 bar is 4/8. Now, if it was a number 5 bar, you would actually have 5/8 times 30, which is 8 divided into 150. So it's almost, you would have a 17-inch overlap. And when it comes to rebar, you have to fasten it together. So how do they do that? They use mechanical fastening and welding, and that's to transfer load from bar to bar. Now let's go to precast concrete. Again, it's concrete basically cast at the plants. You have your RCP, which is your reinforced concrete pipe. You have your box culverts. They're also made at the plants. And basically, your box culverts, they're what we call pre-stressed. You have your cable, pull everything together, and you seal them up. And usually, precast concrete is transported to the job site and installed. Now, casting is basically done in a controlled environment because it produces a higher quality product. Now, for DOT, you have inspectors there to make sure that they're putting the proper stamp on it and it's meeting specifications. So some buildings can be constructed using precast concrete. Again, this is precast concrete. This is a warehouse. Now you can actually form up one of these panels. It's called tilt-up construction. And you have your pre-stressed concrete. This goes again back to your box culvert. Uses cables to pull together the lower half of beam before a load is placed on it. Now, pre-stressing members puts the concrete into compression. Now, again, tension is when you pull down. And in structural engineering, it's always the smile. Now, when you have the compression, that's a heck of a lot different. Compression is you're pushing down. You're pushing down. Tension, the force goes up. Now, you remember this, concrete is much stronger in compression. So pre-stressed members use less material than conventionally reinforced members. Half the concrete, 1/4 of the steel. That's why it's cheaper to do everything in pre-stressed mode. Again, here you go. Here are the diagrams. Here's your post tension. You have your beam cast around cable, and you have your you have your pre-tension and your post tension. Again, you can check the video out. Has everything you need to know. Now we get into steel. Steel offers a different type of ornament. And there are different types of steel members like your I-beams, your webs, your angles, pipes, channels, and T's. Again, common structural steel members are basically girders and beams, spandrel beams, columns, and trusses. Again, you have different structural steel shapes, like you have what we call your W beam, that's your wide flange beam. Your M beam is miscellaneous. Then you have your C beam, your basic I beam. You have your angle beam, which is your L beam, and you have your miscellaneous channel. And they have typical destinations, like you have your W21 What that is, it's a W beam, and it's your depth 21 by your poundage 147. And your nominal size is 21 by 13. And your W is your W beam. Again, more structural steel shapes. And you have your structural steel members. Floor loads are basically transferred to beams. Load transfers from beams to columns. Columns transfer loads down to the foundation. Now, this is very important because if you're getting all of these loads, if your foundation isn't strong, then you're going to have a collapse. And this is what I believe happened to the building in Florida. Now you have your open web steel joists. They're used for floor and roof structures. There's also support beams. They're basically more efficient than wide flange beams. And of course, joists can be top bearing or even bottom bearing. Again, if you want to know more about your steel, there's this big manual, and I actually have one. It's by the American Steel Institute. It's a black manual, it has all the specifications and labeling. Everything is by the steel. Then if you want concrete, you have the American Concrete Institute. Open web joists for buildings. Open web steel joists. And you have your metal decking. Now, usually a lot of your metal decking comes in your bridges and some of your buildings. Here's the diagram. You have a wall section right here. Now, again, here's something very important. Careers in construction. And this is why I do the STEM channel. Because if you want to know about steel, construction, you could be an engineer or a construction manager. Now, the engineer, basically a civil engineer, plans and designs construction projects. Now, you have different branches of civil engineering. Now, the civil engineer, for the most part, does the roadways, bridges, and canals. Now, you have a structural engineer, which in turn is a civil engineer, and basically a structural engineer determines physical components of structures. Now, to be an engineer, you have a couple of requirements. You need to first get a minimum of a bachelor's degree. You can get a master's degree. You have professional experience, and then you pass a couple of licensing exams. So when it comes to any type of building, understand that the structure is the biggest part of the building. Structures are the ones that carry the loads, but your load is supported by your foundation. This is why a good geotechnical engineer who can analyze soil will give you an idea if the soil is suitable enough to actually put down a footing. But once again, when it comes to steel, when it comes to concrete, when it comes to wood, when it comes to framing, they all come under steel components. When it comes to schedules, you have your beam and you have your column schedules. You also have your rebar, you have your chairs, you have your stirrups. Again, you have pre-tensioning, you have post-tensioning. You understand structural, you can have a good career. But what I'm doing tonight is giving you an overview of what's involved with structural plans. I'm giving you an indication of steel components. So again, Structural components are the bread and butter of a building. Now, you can't have your structural components without the footing, but it's your structural components that carry all of your loads. Because you think about it, you have a roof that's transferred to your columns. Columns transfer the load right down to the footings. Also, your columns transfer loads to the beams and your joists. Again, when you're dealing with structural components, you're dealing with components that actually take care of all of your loads. And once again, that concludes this segment on steel components and structural prints. If you like what I just presented, please comment, share, and subscribe. And again, you are listening or you're viewing the Mind of STEM channel. On this channel, I give you a daily dose of science, technology, engineering, and math. Now, if you're looking for some political content, find me on the 401 Talk Zone radio show on Blog Talk Radio, and of course, YouTube as well. Guest calling number is 215-383-5785. Now, if you cannot find me here on the Mind of STEM channel or the 401 Talk Zone radio show, you can always find me on Twitter, MeWe, and of course, Parler. Now, because I'm doing design, you can also look at the first two videos that I did because it all goes in order. The first video I did tonight, site analysis. Then I got into design concepts. Then I got into steel components. All important when you're designing a structure, because if you build a building properly, it will not collapse. If you design a building properly, it will not collapse. So in the end, lives are saved when we pay attention to what we're doing as engineers, architects, and construction managers. And again, I want to thank you for listening to this edition of the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. And until next time, my name is Leon Jones. I want you to have a wonderful and gracious night. And once again, thank you for listening to a triple header tonight: site analysis, design concepts, and structural components. I want to say God bless you. You have a good night. And I'll see you on the next video. God bless you.